another episode here in the series where I'll be walking through an exercise that involves translating Roman numerals into a number, or what do you call it, an actual number, so our decimals. Yeah, so turn it into decimals. So imagine you have these, as you see on the screen, these MDCCCLXVII equals 1000 equals 500. So we will assume that the M is for 1000, the D stands for, so we can do this, so like, we can see it here actually. So the M is 1000, the D is 500 in decimal numbers, and the C is 100, so that's times 3, since it's written that way. So this is our system, and then the L is 50, and X, I probably know that's 10, and 5, V is 5, and I is 1. Okay, so we have some kind of system here, and we have to figure out how to get the decimal number from any given Roman numeral, and then afterwards that we have to write unit test. So the first part is up here, and then we have the second part here. So that's writing unit test. And I have a video before about live coding also in unit tests. That's where we could doing a calculator. You can go and watch that. That's also a brief introduction to that. And we'll be probably doing some of the same stuff here, right? Or just in a different way, because this is not just adding. This is like cracking or decrypting these kind of ciphers, if you would call that. So we know the schema. We know how these are decrypted, and we'll be doing that, and then I'll perhaps add some negative and some positive tests that we didn't do in the other section. So what we need to do, we will do we'll make a class at first. So we will say that class, and then we will call it Roman numeral to decimal. And just called by this. Inside this class, we will have the def init to instantiate the class, and yeah, and then we will use these. I'm not sure which attributes we'll be putting in right at the moment. So now we at least have this skeleton. So, and this needs a return statement. No, that actually doesn't, as I recall it. So I'm a bit rusty, or I'm a little new beginner into Python coding classes. So we have made this so far. So what we see is this schema. So I think we will try to use some if-else sentences. So we could, in this class, we could write a self, so referring to the class itself. And for that, and we will also be using some a numeral. So we will take the Roman numeral. I don't know if that's vocalized correctly or how you say it. That's a string. And then we will also, yeah. So actually we just take the string in, and we could say self dot Roman numeral equals numeral. Okay. Yeah, that's actually with down here in the instantiation of the class. So I'll just be checking here if we are on the right track here for making the class. I have this. Yeah, so we'll be doing this. Yeah. self numeral. Yes. Okay. So first, okay. So now we'll have defined what is going to go inside the class, and we've instantiated it. So let's try to make a method that could help us in deciphering this mysterious numerals that's going to get in here. So let's go up here, and we have this relationship here. So we also have some rules. So it has to follow these relationship. These are some rules, and then we have to also remind us that large values preceding smaller are or equal. So perhaps we should somehow implement this sign. So if how could we say that? State that larger values preceding smaller or equal ones keep their value. So if there's something preceding, so repeating. So if the character, the char before is equal or smaller, which is this way we simplify that or logically express this, then current value. So looking through the array of values, then we could say like something like then it should keep its value. So we should be it should not be changed. Yeah, okay. So keep value. Then keep value. So okay. And there's an example of how it does. When a value precedes a larger one, it means subtraction. Yeah, so that's another rule. So we could do like this, larger. So I think keeping the original text from the assignment. So rule 1 equals, and rule 2, if when a value precedes a larger one, it means subtraction. So when a value precedes a larger one, it means subtraction. So when a smaller, I assume that smaller, because a value that doesn't give us any information about what's going on here, the relationship, because that's obviously something it says here. It says larger, then we assume that it's a smaller value. So if char at 0, so at the current place, if char at current, if current character is precedes, so that's where you get like this one. So I before v, then you have to subtract if a smaller value precedes a larger one, it means subtraction precedes. Precedes. So it comes before. But here we have this example here, so that doubles up. This just keeps its value here, so times 2 plus that's okay, yeah, so 5, yeah, so but if it was before that, so 1x will, I think, value precedes a larger one. It means so okay, here. So if x then you should subtract. Okay, so if so charge if is okay smaller than char 1, then subtract. Okay, well, we could use our calculator from before. So actually, I'll be calling this calculator. So I'll try to import import. Let's just try to move it up here. So import calculator from calculator. This is the way I did it. Why is it doing that? Yeah, from, sorry. Import. Okay, class Roman numerals to decimal. Diff init. Okay. So so we have these rules. So if you have a Roman, so like diff convert to decimal, and then we will taking self. I think we also have to the self, and then we should go for first. I think we need to, the Roman numeral needs to, we take that. So I think we use a for loop. I don't know actually how that is done in Python, so I'll just be consulting here with a expert. So me set up a for loop in Python. List a tuple dictionary. Okay, so I think we will try to use a list. Our string, we'll use a string and iterate around that. Break continue. Or maybe perhaps we could use this. Skip. Okay. Break. Yeah, perhaps we should use a nested loop. Try that. Nested loop with string. Yeah, so we're comparing characters from two strings. Yeah. So I'll just be char one string. I'm just trying to use this. So our string 1, Roman, then we will probably use a list. So that's with the perhaps we should use actually a dictionary. So how does that do? Start dictionary and list. Checking string and dictionary. So I think here in this case, yeah, we should use this. I think we can easily go with that. We can have the string, and then we can have a dictionary where you have the key value. It's like I know that from Java set where you have the key value pair. So you have a key and an associated value, and then you can easily check if this exists in the dictionary. So here it explains here what it does here with hello. The outer loop iterates over each character in the string my string. For each character, the loop checks if it exists in the key my dictionary, using if char in my dictionary statement. If the character exists in the dictionary, the corresponding value is printed. So what we should do is we should save it and then add it together. So multiple strings and multiple dictionary and dictionary. So you have more strings here. Yeah, interesting. Case sensitivity. All right, let's try to check this one. So we'll just indent this, indent this, indent this. Alright, that's so we have my string here, so that's our self dot yeah, okay, that's so my this should be this one. So yeah, so let's just fill in a dictionary with see, that's very useful. I can do this. So if char is in what do we do here? Let's go back and check here the original statements here. So yeah, so we would just too quick self dot Roman numeral dictionary Roman numerals. Let's just check this. Oh, we forgot something, I think. Oh, so this one. How should that be? Unexpected indentation. Oh, yes. Oh. Wait. Unexpected indentation. Oh. Maybe I have to make a return statement. No? But convert, yes. gave us the solution there, but we are just going to check here. So it's hot here. I'm sitting right in the sun, so it's become right hot here. I think it's 28 degrees outside. It's insanely hot today. Yeah, in Denmark. Denmark. So I think we should go here. So we get the char here in self dot Roman. No, in dot self dot Roman numeral. Yeah. Let's try to run this. Okay, so for the char characters in this string, so dictionary, but I don't think we can do this actually. So try to just need some help here. So okay, compare dictionary. Alright, let's just try to take the solution and walk through it. See what it gives us. It's quite good at programming. Or at least compared to this. I'll just not be using this calculator. So yeah, if the value is from the previous value, let's try to check here. It's 14. That looks correct. So value equals previous value. Where is here total? So value. Okay, so now let's try to write some unit tests with it. Okay, let's just ask it as the number programmer in Python, and is this the fastest algorithm? Context of the specific needs. Let's dive deeper into the algorithm's efficiency and the possibility of optimization. Can be optimized. X correctly handle subtracting case like. ensure that the Roman character handles like Roman non-character. This is more about robustness. Speed per compression issues large system parallel processing for extremely minimize comparisons. Marginal range. Okay, super. So this is good. Tools that time. Okay, right. Unit tests. Testing negative and positive cases. So I would really like to also do this more in depth, but in terms of time constraints, I'm now sketched up the general idea I wanted to implement. So this must be, and I think you also have to somehow embrace that these tools are available for generating this type of code. Okay. Ensure. Okay, so I think that looks a bit mysterious here. So let's try to self-reflect. Take a deep breath, and use industry best practices and act as top Harvard computer HD Python programmer implementing act arrange act and assert. Ensure the self-reflect and check for correctness and efficiency, including edge cases. Okay, we're just implementing this and taking this It's incredible. Failed 7 failures. Okay, so it actually uncovered some mistakes that it did not correctly. Yeah, so we had to adjust the code. That's interesting. So that actually shows that we have something improvements to do here that it assumed in the first run. Interesting. So errors, 1 error now. Okay, so we're improving. Fantastic. Actually, we should be writing down how many errors it's doing here. So just to I don't know where it actually starts. Let's really look for the red dot here. So let's see if we can improve this. So I'll just ask it to take a deep breath, self-reflect, and very much critique the code like a tough code review with multiple experts. Convert to decimal. Incorrect handling of invalid repetitions. So it's good at setting up tests and failing. Instead of empty strings enter serious stuff instead of none. The method doesn't handle the case empty strings explicitly. A return condition if the converted. Okay, consistent validity checks. Sequence. Checking. The method is not checking the order of the combination of problem. Okay, validation logic and revised implementation plan. Cohesion. Yep, I understand why this is so useful. So let's try to once again. I must declare it's much better than me at coding and finding errors in a really really quick manner. Let's try to look here. Okay, so now we have one failure again. Failed when. Let's give it here. Okay. Self-reflect. Take deep breath. Carefully examine the error and adjust the code. Numeral incorrectly returns a value. So